Hi everyone. In part 1 on sampling, we looked at some definitions and a little bit of theory. This is now part 2, where we will be looking at selecting samples using probability sampling methods. Now, just a reminder, probability sampling is when all the elements have a chance of being selected, and it doesn't necessarily have to be an equal chance. Non-probability sampling is when not all the elements have a chance of being selected. We have our subset that come from our population. The things that describe the population, those are called parameters. We can't measure them because usually populations are too big, so that's the reason for the subset. When we have our subset, we calculate the properties of the subset and we call those statistics. Those are estimates. If the sample is unbiased and representative, then we can generalize or infer the sample results to the population. In other words, we hope that our statistics, in other words, our estimates, we hope that they are reliable because we have an unbiased and representative sample so that we can extend those results to the actual population. Right, now the first probability sampling method that we'll look at is simple random sampling, which is the most common one that is used. Now, we use simple random sampling to avoid selection bias from the population. Right, in other words, we don't want our choice to be influenced by external factors. So that's why we select a random sample. Now, if it's a random sample, then every subset of a specific size, and the size will be size n, will have the same chance of being selected. Okay, so every subset of size n will have the same chance of being selected. Now, we will look at that in a little bit more detail in the section on probability and counting techniques. Now let's look at an example. Suppose that we have a class of 30 students. Now you'll notice I've just written here student 30 times. That is because it doesn't make sense to write names. Some people share names, some people share surnames. So there's no way in identifying somebody uniquely only by their name. So what we'll do is we will number this population of students from 1 to 30. So these numbers are not really counting or measuring anything. They're simply labels. It's like an ID number. You'll notice that we have a population, of size 30. The 30, that's a double digit number. So we'll start with a double digit, 0, 1, and then we'll count 0, 2, 0, 3, 0, 4, 0, 5, all the way to 30. It's very important that the labels that we use to identify our elements in our population have the same number of digits. Right? This is for selection purpose. Otherwise, our sampling method will not work. Right, now, once we have labeled all the elements in our population, okay, this is a very small population, just for the sake of the example, but once we've labeled all the elements in the population using double digits, then we can either use what we call a random number table, such as the small random number table I have here, or we can use our calculator or a computer with software such as Excel in order to select our random sample. Now, in the case of my example, I'm interested in selecting a sample of size 6. So what I'm going to do is I'm going to start top left in my random number table, and I'm going to look at the first 2 digits. Now the first 2 digits is 99. 99 is not a student label. The maximum is 30. So that means 99 is not an option. 43 is the next pair. Okay, I'm looking at 2 consecutive digits because I have 2-digit labels. 43 also does not appear. The next one is 78. 78 also does not appear because the maximum is 30. And the next one is 79, also not. 61, that's not there. 45, 73, again 73, 75, 52, 97, 96, 93, also not there. 90 is not there, 94, 34, 47, 53, 16. So that means 16 will be the first student that will be selected from my population for my sample. The next one, 18. That will be the second student selected. Then we have 50, 65, 60, then 01. So the first student. Then we have 27. So that will be the fourth one. Then we have 68, which is not there. 36 is not there. 76, 68, 82, 08 is there. That is the fifth student. And the last one is 15. So that is the sixth student. Now, if I need more students for my sample, then I'll simply carry on with this list. You will notice that over here I have another 16 coming up. But because I've already selected student 16 earlier on over here, I'm going to ignore this one and carry on because I don't want the same student to be selected more than once for my sample. Right, so important, the labels must be the same number of digits so that we can use our random number table. You'll see on the table we have these gaps between the numbers to create columns. There's no specific reason for that. Some tables have them, some tables don't. They're simply a continuous list of random digits. Right, so we ignore these spaces and we treat the two consecutive digits as if it forms one number. Right, now if we look at our resulting sample, then we see that we have student number 1, 8, 15, 16, 18, and 27. Now really important to note, these are the ID numbers that was selected from the population. This is not the actual data. This is like having a list of ID numbers, right? A list of 6 ID numbers. It doesn't tell us anything about the element that was selected, right? It doesn't tell us anything about the student that was selected. Once we start gathering information from the students, then we'll have data. So if, for example, we ask the student what degree they are doing, then that will be data that we're collecting. If we ask them what is their height, then that will be data that we are collecting. But as it is here, it is simply a list of ID numbers. Right, the next one is random cluster sampling. Now, random cluster sampling simply means that the population is divided up into clusters or groups, but we call it clusters preferably, and within these clusters we have diversity. But between the clusters we have similarity. So that means each of these clusters are very similar to each other, but the elements within the clusters are very different. So if we think of it in terms of a population, like the population of the country, then we can think of each one of these clusters as being one of the main cities in the country, where you will have very big diversity within a city, but when you compare the cities, you'll see that they are very similar to each other. So all that we do is we identify the clusters and then we use our simple random sampling. So in this case I have 5 clusters, so I'll simply number it 1, 2, 3, 4, and 5, and then I'll use my random number table to make a selection. So let's just say that I end up with those 2. Okay, and that will be simple random sampling. In other words, the first method that we looked at. Right, the next one is stratified random sampling. Now this one may seem a bit like cluster sampling, but the properties of the groups are opposite. So let's see what we mean by that. We have a population. Now please note that the population does not necessarily mean people. Population in statistics means all elements that have a specific characteristic that you wish to investigate. I'll repeat that. Population in statistics means all elements that has a specific characteristic, a specific property that you wish to investigate. For my example, I'm using a human population. Right now, stratified sampling simply means that we take our population, whatever it is, and we split it up into groups. Now these groups are called strata, hence the name stratified sampling. Okay, it's very important that you know the terms. So we'll split the population up into strata, into different groups. However, it's not the same as clusters, because you will notice here, within each group, I have no diversity. The diversity lies between the groups. So in other words, I'm looking at a characteristic that enables me to clearly distinguish between different groups. So for example, the top group here could be students in the education faculty. The second group could be students in the science faculty. The third group, students in the arts faculty. And the last one, students in the commerce faculty. So that's a property that distinguishes these groups of students from each other. Within each group, I have no diversity. So if you're in the commerce faculty, then you'll be studying something to do with commerce. So whether it is business management, whether it's accounting, or whether it's economics, you will be part of that group, and the same for the others. Now, once we have these different groups, different strata, then we will select from those groups. Once we've made our selection, we'll combine our selection, and that will give us our sample at the end. Now you'll notice here I said NB ratios. Now that is the whole point of stratified sampling. Let's say, for example, that I have a population of size 200. And let's say that of those 200, 40 people are in the first group, 80 in the second, 60 in the third, and 20 in the fourth. It's a very small population. So that means that out of the 200, 20% will be in the first group. It's 40 out of 200. That gives me my 20%. So in the second group, I have 40% of the population because it'll be 80 over 200. And the next one we have 30% of the population because it's 60 over 200. And then the next one 10% of the population because it's 20 over 200. So when we select our sample, we need to select according to these ratios. So if I'm interested in a sample of size 10, then 20% of my sample must come from the first group of 40. So 20% of 10 will be for the first group, and that gives me 2 people. So that means I will use my random sampling method, right? The simple random sampling that we started with. I'll use that method to select 2 people from this first group over here. Next we have 40% of 10, right? 40% because 80 out of 200 people belong to this group in the population. So that means 40% of 10 from our sample must belong to this group as well. And we see that that's 4. So carrying on, we see that we have 2 people randomly selected from the first group, 4 people randomly selected from the second, 3 randomly from the third, and only 1 person randomly from the fourth group or the fourth stratum, right? Because it takes up the smallest portion of the population. Right, so really, really important that you keep the ratios in mind because that is the whole purpose of stratified sampling, is attempting a representative sample from the population. Now the last one is systematic random sampling. Now systematic random sampling is exactly what the name says. It is systematic. So that means there's a pattern. The pattern we call our sampling interval, and we denote it by a lowercase k, and it is simply the population size divided by the sample size. So let's have a look at an example. Suppose that we have a population of size 50. So here we have 50 businessmen standing in a row, and from that population of size 50, we want to select a sample of size 5. Now according to this, the sampling interval will be 50 divided by 5, which is 10. So that means the pattern that we select according to is 10. Now let's see how we actually do this. Firstly, we will randomly select a person. So that means we will number the population from 1 to 50, and then we will use our random number table to select two consecutive digits that give us a number less than or equal to 50. If you go back to the random sampling method that we started with. Now let's suppose that I've randomly selected the first person, and I see that that person is number 23. Okay, so that person is number 23. Now, who will be the next person? Well, seeing as the first one is 23, and the pattern that I need to follow is 10, it means that the next person will be 23 plus 10, which is 33. So the first person will be 23, and then the next person will be 33. Then I take the 33 and I add 10 to that. So that gives me 43 now as the next person. Now I need to do this 5 times because I want a sample of size 5. Now if I do this again, then the fourth element that I select, or the fourth person that I select, will be 43 plus 10. But that's going to give me 53. I don't have 53 people here, I've only got 50. So what we do is, we'll take 53 and we'll subtract 50, which is the population size. And that will give me 3. So that means I go all the way back to the beginning and I restart my list. Because remember, I skipped the first 22 people because my first person that I selected was number 23. So there's 22 others that I haven't considered yet. So by doing this, I'm going back and I'm considering them as well. So that means if I take 43, I'll add 10. I'm going over my population size, so I'll subtract the population size, and that will give me 3. So that's the next person. And then the last one will be 3 plus 10, which is 13. So there I have my sample of size 5. First element is person 23, then 33, 43, then we go back to 3 and 13. Now again, very important to note, these are the sample points. In other words, they are the labels. This is not the data. This is simply the list of people that I will be studying. So once I start asking them questions, getting information from them, then I'm starting to collect data. Right, now the next one is non-probability sampling. Now, non-probability sampling is used in very specific cases where we have, for example, case studies where you're only interested in a specific group of people. Now, the limit of non-probability sampling is that it doesn't allow you to generalize this process over here. It doesn't allow you to take your sample statistics and infer it to the population or generalize it to the population. And if you want to do that, you have to be really, really careful. But for our purposes, our focus will be on probability sampling because everything that we do in this course will be based on probability. But now, just for the sake of interest, we will have a look at these 4 popular non-probability sampling methods and just look at what each one is. Right, first one, judgment sampling. Well, that's very easy. The sample elements are selected according to the judgment of the researcher. So the researcher will have certain criteria, and according to that, he will select the people for the sample. Quota sampling is a lot like stratified sampling, but remember, non-probability method means that not everybody has a chance of being selected. So here, once again, you're using judgment because you're selecting according to certain criteria. Snowball sampling. Now, snowball sampling is where you are referred to other people by people that you've already selected. In other words, you will select the first person for your sample, and then that person will refer you to somebody else who they think might be of interest to you to include in your sample. The next one is convenience sampling. Now this is quite a nice image. Unfortunately, I don't remember where I got this from. but it's literally a person hanging out the bedroom window and asking the first person who comes by Coke or Pepsi. So it's probably what they like. This person is interested to find out what this person likes, but they're too lazy to select a random sample, which is quite a task, and they simply lean out the window and they ask the first person that comes by. Right now, I just mentioned that simple random sampling is quite a task, and that takes us to advantages and disadvantages of the different sampling methods, which I will leave to you for self-study.